Hey students, welcome back. This is Torres, Elbow Bump. How are you? Are you doing okay? Is your family okay? Remember, if you need anything, please send me an email so that I can try to help in some way or another. So lucky you, you get to hear my voice for another lecture. But the best part is we will be reviewing the equation of a line. Yay! So first off, this review is a very superficial review of the equation of a line and how to interpret the equation of a line. I really want to focus on these more fundamental pieces because I want you to have enough of a review so that you can interpret the output as we need it. So I want to start by just talking about two major features of a line. There are four different types of slopes. Let's look at this figure first. Here, if you see this line right here, we can see that this line tends to increase from left to right. Okay, as we go from left to right, this slope increases. When a line seems to increase, we would say that it has a positive slope. The exact opposite of that is when we get a line that seems to decrease. If a line decreases, then that is considered a negative slope. Just like on a number line, the slope that would be exactly in the middle of a positive slope and a negative slope would be a zero slope. So a zero slope is perfectly horizontal. Here, the undefined slope is the last category, and this one is completely up and down, okay, completely vertical. It is not tilted in any way. And so this would be called an undefined slope. So just being able to look at the slopes that are created in a graph, for example, and understand if you have a positive slope, if you have a negative slope, if you have a zero slope, or if an undefined slope is showing up, is really important in statistical inferences. We use the letter M to represent slope. And if you're wondering why, just a little fun fact. So see this guy right here? So this guy is René Descartes, and he is actually the person that created the Cartesian plane that we talked about in our graphing points video. He developed the idea that the x-axis should act as a number line that is horizontal, and the y-axis should act as a number line that is vertical. And when we started talking about lines, when he was developing the equation of a line, he thought that M might be a good letter to represent slope because he felt the slope reminded him of how mountains have slope. So he was French. He wasn't using the word mountain. He was using a similar word as mont, M-O-N-T, that also starts with the letter M, and that's where that M is coming from. So it's not completely out of the blue. So let's look at the slope in a line and how we can describe it. Let's look at this picture. Okay, we have the x-axis that runs through here, and we have the y-axis that runs through here. And across that, we see that there is a line that crosses through quadrant 1, quadrant 2, and quadrant 3. So that line is going through right through here. Okay, and the line is positive, right? We see that it's increasing as we increase the x-axis. As we move up the x-axis, we also kind of move up the y-axis. We know that there are 2 points that are available for us to evaluate to find the slope. So the slope can be considered to be the change in the y-axis, or the rise, over the change of the x-axis, which is called the run. So when we look at this point and this point, we can see that if we look at the y-axis, that would have changed by 1, 2, 3, 4 units, right? So that could be the change of y, which is considered the rise. The run would be how much it changed on the x-axis. It went from being over here in the x-axis to being over here in the x-axis. So that is a change of 1, 2, 3, 4, 5 units. So that would be your run. So if we were just going to write this as a fraction, we could just say the rise is 4, and that would be over the run. Okay, that's all this is describing. And that's really all you have to take away for the statistical point of view from the statistics. Slope can also be referred to as the rate of change between those 2 points. So basically, we're looking to see how much the x will affect the y. In statistics, we use the x-axis for our independent variable and the y-axis as our dependent variable. So in that way, the slope gives us information about a possible relationship between the independent variable and the dependent variable. So the equation that summarizes the attributes of a line can be written as y equals mx plus b. In this situation, the slope would be whatever number is in place of the m, and the y-intercept would be whatever number is in place of the b. Let's look at an example. Here I have the equation y equals 3x plus 1/2. Because 3 is here where we would expect to see the m, we can say that the slope is 3. Okay, that's the information that we can extract from this. Because the 1/2 is taking the spot of the b, we can say that the y-intercept is 1/2. Okay, so just the way that the line is being expressed here in the slope-intercept form, we can quickly take out the information that we need. The slope is 3, the y-intercept is 1/2. In statistics, for whatever reason, we actually use the order b plus mx, but it's the same thing because you're just moving the numbers around. So this is the same exact equation that we saw in the previous slide. Here, the slope is still 3 because it's the number that's before the x, and the y-intercept is still 1/2 because it is the constant value that is out here. It just moved the order of the terms around by using the commutative property. In statistics, you'll see it in this order. Remember, x is our independent variable and y is our dependent variable. Let's talk about the y-intercept now. So here in this diagram, we see that we have the x-axis here. In statistics, this would be the independent variable, and we also have the y-axis here, and in statistics, this would be the dependent variable. So those are in black. And then in blue, we have a line that is crossing through the first quadrant, the fourth quadrant, and the third quadrant. Okay, and we can see that they have just gone ahead and set aside 2 points for us to use. So let's just look at the slope first, because we already talked about the slope. Remember, that's the change of the y over the change of the x. So the y is up and down, right? It's the vertical change. So here we have that there was a change of 1, 2, 3 units. And now we need to know the horizontal change, which is from here to here is 4 units. 1, 2, 3, 4. So we can say that the slope here is 3 over 4. The last piece of information that we need is where does the blue line touch the x-axis? And we can see that it touches the x-axis at the point 0, -2. So the y-intercept here is -2. Okay, and this is what we have here. I'm not asking you to do any algebra at this point. You're just actually having to extract the information as needed, be able to interpret the information as needed. Here we have the equation of a line, y equals 3 over 4x minus 2. These examples actually have you create the equation of a line using information provided. So in this one, they've gone ahead and provided the slope m as being 3 and b, the y-intercept, as being 1. the answer that they're wanting you to give is y equals 3x plus 1. And as you can see, all they did was substitute in the numbers where they belong. This is very much like what you would do with statistical output. You would give your dependent variable, write an equal sign, write what the slope is of the line, write the independent variable, and then add the y-intercept. So this is very much aligned with stuff that we're going to be doing here in a minute. For this one right here, we have the same thing. You were given m equals -2 and b equals -4, and so you would get the answer y equals -2x minus 4. Finally, here, same type of deal. You just plug them in. Notice that sometimes, and I'll just give you the heads up on this, sometimes with negative signs and equal signs, we just don't see them very well. So you just want to be careful that you are actually carrying the negative through if you're given a negative slope or a negative y-intercept. So here with a slope of -3/4 and a y-intercept of 7/2, your answer would be y equals -3/4 x plus 7/2. So what's the big idea? Today's big idea is lines can be described by using the formula for the equation of a line, which is y equals mx plus b. The equation of a line describes the steepness of the line and the direction, whether it's positive, negative, zero slope, or if it's an undefined slope. Also, it describes where the line intersects with the y-axis. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course. Okay? This is your teacher, Tora, saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video.